This video is on exponentials and logarithms. I'm doing example 3 of converting this or writing the inverse for this function, and then we're going to state the domain and range of the original and the inverse. So for the original domain and range, this is a logarithm. When it is a logarithm, the domain has an asymptote. So for the domain of this, the asymptote will be at whatever your h value is. So if I solve this for x, I would end up getting 0 because the h value would be 3x minus nothing. So our asymptote is at 0. It's an asymptote, so it doesn't actually touch it. That's why it's an open bracket. But then it will go off to the positive infinity because we have a positive x in here. The range on a logarithm is negative infinity to positive infinity. So if we can go ahead and get our inverse domain and range, it's the flipped version of our original. So the domain of the inverse will be that negative infinity to positive infinity. And the range of our inverse will be that 0 to positive infinity with open brackets on both. To find the inverse, we need to change our v of x to look like a y. And then we just rewrite this. We switch the x and y's. So the y will become an x equals log of 3y. You want to make sure that the log, starting with the L all the way to the end of the parentheses, is alone. There's nothing attached to the L and nothing attached to the end of the parentheses. That means that we can go ahead and convert this. We want to convert this into an exponential. Now what you need to know about this logarithm, you don't see the base down here, but this is called a common log. The base on this one is automatically a 10. So our base is 10. The base is always going to be the base. So we're going to have this 10 raised to an exponent. The exponent never touches the log. So the x is not touching the logarithm. That'll become our exponent. So 10 to the x is equal to what's left is that 3y. We're going to divide by the 3 to solve for y. We'll have 10 to the x divided by 3 is equal to y. So our inverse equation would be v inverse of x is equal to 10 to the x power divided by 3. Again, your range has an asymptote at your k value. Now this has plus or minus nothing on the outside, so your k value is 0. That's why our range has an asymptote at 0. So that means that we did find our domain and range correctly using the original to find our inverse. On this next example, we have an exponential. If you have an exponential, then the domain of the original will automatically be negative infinity to positive infinity. Your range, you will need to find from the k value that's actually added to the outside, but we don't see any. We do have this k value out here. So if we look at this, we have 3 to the x minus 9, but it's all over 3. When you have a subtraction of fractions, you have to have a common denominator. So if these are both divided by 3, then if we put them back together, it will still be divided by 3. So we split them up using the same denominator on both. Your k value comes from what's ever added or subtracted away from the base. So this negative 9 divided by 3, this is really 3 to the x over 3, because I'm just going to keep that the same because I don't need it right now. But this becomes minus 3. So our asymptote for our range is at negative 3. And because it is going to go up because our a value is positive, it will start at negative 3, it'll be an open bracket, and it will go to a positive infinity. You had to actually find the k value by understanding that these two values in the numerator can be split apart as long as they both still have the same denominator. And then we can simplify as needed. We only actually needed the negative 9 over 3 because that was the k. That's what we needed. I didn't have to simplify this part. So therefore, the inverse domain and range, the domain of the inverse will be that -3 to infinity, open brackets, and the range will be -infinity to positive infinity. Again, you just need to know where your asymptotes will be. Go ahead and change your g of x to, say, a y, and then we will rewrite this, flipping the x's and y's. We'll have x equals 3 to the y, and then that minus 9, and then all of that divided by 3. We need to get the 3 to the y because it's the base, and whatever's in the exponent, that has to be alone before we can even try and convert it. So we have to undo everything that's attached to it. So that 3 on the denominator, we need to multiply away to the other side to get it off the denominator. So this will become a 3 times x is equal to a 3 to the y minus 9. That 3 to the y still needs to be alone, so we have to add this 9 to the other side. We'll have 3x plus 9 is equal to 3 to the y. Now that we have the base and its exponent alone, we can convert it to its inverse form. The inverse of an exponent would be a logarithm. So I'm going to go ahead and write the word log. We know we're going to have a base, something in here, and an equal sign. So just remember, the base is always the base. The base is what's attached to the exponent, so your base is 3. This will be log base 3. The other helpful hint is the exponent never touches the log. Well, the exponent is the y. That cannot touch the log, so it has to be on this side of the equals. What's left is this entire 3x plus 9. This entire thing goes in parentheses, and it's in that empty space. So our inverse equation would be g inverse of x is equal to log base 3 of 3x plus 9. And again, if you needed to find the domain, the asymptote for the domain, your 3x plus 9 has to be equal to 0. So we would subtract the 9, then divide by 3. That gives us -3. So again, we need to make sure that we get the pieces alone that need to be alone before we can convert to an exponential or to a logarithm, the inverse format. On this next example, we have multiple things attached to an exponential. So we can go ahead, as always, find our domain and range. The original. This is originally an exponential, so the domain is always going to be -infinity to positive infinity as long as your first value is positive, your a value is positive. So it will be at -infinity to positive infinity. Your range has an asymptote at your k value. Our k value is already by itself, it's that -5. So our k value is -5, and it will go up to positive infinity. So again, asymptote means it won't touch that -5. So for the inverse, the domain will be that -5 to infinity, and the range will be -infinity to positive infinity. Now to find the actual inverse, always start with making sure this says y equals. Now we can switch the x's and y's. So this will become an x equals, we have a 1/2 times 4 raised to the 3y minus 4, and then -5 on the outside. Now there's a lot of things that are attached to this. This 1/2 and the 4 cannot actually multiply to each other because this 4 has the exponent and the 1/2 does not. So the 4 is your base. The base and its exponent have to be alone. So we have to get this part alone. It means we have to get everything else away from it. So order of operations, if we're solving, meaning that we have to get the stuff alone, we have to add and subtract first. So we're going to add that 5 to the other side first. We're going to have x plus 5 equals 1/2 times that 4 raised to the 3y minus 4. So again, we want to get this base and its exponent alone. We want to get rid of this 1/2. Now you can divide by a 1/2, but that's a little tricky because you don't have just numbers. But you can multiply by the reciprocal, and that gets rid of that as well. The reciprocal of 1/2 is 2. So if we multiply by 2 on both sides, it gets rid of the 1/2. But multiply x plus 5 by 2, we get 2x plus 10 is equal to that 4 raised to the 3y minus 4. Now that this 4 and its exponent are alone, we can now convert it to its other form. So it's exponential. The inverse form will be a logarithm. So we can go ahead and put the word log. We know there's going to be a base, there's extra stuff, and we're going to have an equals. So our base is always the base. So that 4 is still the base of this logarithm. The exponent never touches the log. So this 3y minus 4 has to be on this side because it will never touch the logarithm. 3y minus 4. So the rest of it, that 2x plus 10, is inside parentheses because that all stays together. That won't change. It has to stay together. Y is not alone yet, so we still have to continue solving for y. So now it's just, we have to add the 4. So we're going to have log base 4 of parentheses 2x plus 10 close parentheses, then add the 4. What's important here is that you do not actually add the 10 and the 4. The 10 is attached to the logarithm, the 4 is not. So it's equal to 3y. So we cannot make this a 14. Do not make that a 14. It is not a 14. Not a 14. This 4 is not in the parentheses. It is not attached to the log. Now we need to divide by 3. So we'll have log base 4 of parentheses 2x plus 10 close parentheses plus 4. All of that over 3 is equal to y. And again, do not do anything with the 3 inside the parentheses. Don't do anything with that because it's not with the logarithm. Now that y is by itself, we have our inverse. We would go back to the original is h of x, so we would have h inverse of x is equal to log base 4 of parentheses 2x plus 10 close parentheses plus the 4, and then all of that divided by 3. That entire thing is our inverse. We have our domain and range. This problem was had a little more to it because we had to continue solving for y in the end.